Here's warm-up number 27. Okay, we're going to dilate this triangle about the origin by a scale factor of -2. Okay. Problem number 2 says find the coordinates of A prime, B prime, and C prime. So after the translation. So I'm actually going to do number 2 first because I think it's a little easier like that. So here, let me just list the original coordinates first. Okay, that's just looking at the diagram there, okay? So if I'm going to do a dilation by a scale factor of -2, I'm just going to take all of those numbers and multiply them by -2, okay? So A prime, I'm going to multiply both the x and the y by -2. So -2 times -2 is +4. -1 times -2 is +2. And I do the same thing with the other 2 points. So I'm multiplying everything by -2. Okay, there's those 2 points multiplied by -2, and then those two. Okay, and there we go. There's the coordinates. And now all I have to do is plot those and draw the triangle that they form. Okay, so A prime is going to be 4, 2. B prime is going to be 2, -4, so 2 right, 4 down. And then C prime is -4, -4, 4 left, 4 down. Okay, and then I just connect the dots to form a triangle. Okay. Okay, and now if we look at what happened here, first off, the triangle has doubled in size. Okay, so the scale factor, this part makes it double. But something else has happened. It's turned around. This point, this corner ended up down here. The whole triangle ended up down here. So it's actually also rotated 180 degrees about the origin. So there's two different things that are happening there. Okay. All right. On problem number 3, this is illustrating, this is the original triangle. Here's the prime one and the double prime one. So if you reflect over 2 intersecting lines, so you reflect it once, it would end up there, and then if you reflect over the second line, it would end up there. And it's the same as a rotation, okay? So this says find the angle of rotation that maps JKL to the double prime JKL. So from this one to this one. And it's tempting to say, oh, look, it's 60 degrees because it's 60 degrees between those intersecting lines. But that's not quite correct, okay? So let's pick a point in the original triangle. I'm going to pick point J, okay? And then if I look where J double prime is in the final triangle, it's up here. So what this is asking me, this problem, is what's if you connect this dot, the origin to J double prime, like so, and you connect the origin to the original J, they're asking what is this angle. And that angle is more than 60 degrees, right? You can see it's more than 60 degrees because 60 degrees is just that piece, right? So it's actually always going to end up that it's twice as much as the angle that's between the 2 intersecting lines. So I just have to double 60, which means I'm going to get 120. So my answer is going to be 120 degrees, okay? All right, last one. Does the figure have rotational symmetry? So if you imagine the center of this figure, this is a hexagon. Can I rotate this less than 360 degrees and have it look the same? Okay. So I just think about this kind of as a wheel. And if I took this corner, let's say, how far would I have to turn this figure until it ended up where that corner was? So in other words, if I did a turn like this, then it's going to look the same as how it started, right? So this does have rotational symmetry. So first answer is yes, but then I have to figure out what the smallest angle of rotation is. Okay? So when I'm looking at this, what I really want to know is, well, what is this angle? Okay? So if you think about taking this corner and rotating this till it gets all the way back where it started, how many turns would I have to do like this? So I'd have 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, and then on the 6th turn, it would end up where it started. So now I can figure out what this angle is because it's 1/6 of the way all the way around the circle, right? So I know the whole circle is 360 degrees. And I'm just going to divide that by 6, which means that would be a 60-degree angle. So yeah, this would also have rotational symmetry of 120 or 180, any multiple of 60, but that's the smallest angle of rotation. Okay, and that's it for this warm-up. See you next time.